So let's resume the class and we can continue the class from here. Let me have the same PPT continued and let me share my screen. So I have here the Zoom meeting. Okay, let me share my screen. So this sharing the screen is enabled. Well, then let that be in the background. And okay, fine. So continuing further. So we just said I have already got this PPT. So I'll just continue here and I'll just have some new slides for F4. Fine. So let's resume from there. So I just said that stability is important and we have seen these discussions. So now going based on the same discussions, continuing with the previous, what we just said, now counting sort logic becomes simple to me. So my counting sort programming, now from this class onwards, there is going to be another change. Till now, I was writing the code mostly for your simplicity and understanding, but now onwards, I will write the pseudo code or main steps and rest you will complete the steps. So first thing is, I have to count the frequency of each value AI. Let's assume this is to be done in array count. Just I'm giving you some time. Make how do you do this? Write down the code for this. I'm waiting for you. Try to write. It's a simple code. You might not be able to develop well, but I will help you. So start doing this code. Yes, must be easy for some of you. Some of you find difficult, but yes, I can help you. For maybe I can say for I equal to 1, I less than equal to n, I plus plus. Effectively, AI is to be counted. AI is a value-based counting is to be done. So think of what to do. For some of you, logic might not come in your mind. So just a try, whatever way, even if it requires another loop, nothing wrong with that. Just a try that. Yes, some of you must have correctly done. For some of you, it might appear that how to write this. Effectively, what you require is something like this. If AI equal to 0, effectively you want count 0 to be incremented. Assuming that initially count is all count arrays declared as with 0 initialization. So I will say count 0 plus plus. Similarly, if you want to say if their value is equal to 1, count 1 plus plus. Well, same way also you can write, but the question is, how do you write here k? Well, on paper you can write dot, dot, dot and equal to k. This k is not fixed. This will be dependent on program to program, data to data. So while writing the code, I cannot write a dot, dot, dot. So you find it difficult how to write. Some of you could find answer, but first time you are not able to think. Maybe then an idea comes to your mind. Yes, I should have something like I equal to 1, I less than equal to n, I plus plus. And then I should have a loop for j equal to 0, j less than equal to k, j plus plus. And then you say, if ai equal to j, then you could say count j plus plus. Yes, that logic you might make like this to do whatever we discussed here. To all this can be done. But as soon as you do this, this becomes a nested loop. And a nested loop means your time complexity becoming n into k times. So you are increasing your time complexity, I can easily see here, n into k plus 1. But of course, we don't want that. So here the lesson is, all this appears the first time that you are not able to think how to do this without having second loop. Actually, it is possible. If you observe carefully, what you need is, if ai equal to 0, you have count 0 plus plus. If ai equal to 1, count 1 plus plus. So all this can be simply done by simply saying that if I have for I equal to 1, I less than equal to n, I plus plus, I can simply say, let's find out the value as ai, and I can directly pass val in as an index, and I'm able to do what I wanted to do. Indirectly, if it is equivalent to saying count where ai plus plus, directly also I can write. But for some of you, this might not come here in your mind in the first time. Don't worry. There is nothing special. Slowly with practice, you will start learning all these tricks. So that is exactly the purpose of knowing all these algorithmic details, so that you know that this can be done without any loop also. Without any if or loop, we are able to get this done directly. And straight away, the time complexity becomes easy. Then I say the second step will be find cumulative sum, cumulative total of the count array. And then third step will be, for reverse of this, for each ai, I will write each ai but I has to be n down to 1. Without syntax, I am writing. So for each ai, you have to place ai at the index found from count array. Find out the count array's index and then place ai. For example, initially I said A12 was 8. So I found count 8. Sorry, A12. Yeah. So A12 value was 8. So I went to count 8, found from this count 8 that this index given to me was, count 12 was a 7, I suppose. Just let me see the previous slides. Yeah, count 12 is a 7. So I'll just correct that. So count 12 is A12 was a 7. That meant that I should go to this count 7 index. I found that index is 11. So in the sorted array, effectively at index 11, I will store the value A12. Value A12 because a full record will be stored. That's why I'm saying value A12 as a collective value. And then I will say sorted 11 minus minus. So that next time this index gets reduced to 10. And once next time the value 7 again comes, that will be stored at index 7. So the rest of the coding, do yourself. Next class, I am going to discuss your doubts, and then we will see if you are not able to do the coding, I will show the code also. But it's easy. From now onwards, make a habit that I'm not going to write the code more than this for you. You have to write the code for this. Going further, any doubts, if you have, are welcome. If you are having no doubts, I will resume, and I'm going with the second algorithm, which doesn't take much time, and it is just extension of the counting sort, is radix sort. But now you can easily see that in case of a counting sort, the time complexity you can calculate. You have 3 steps, each have step 1, we could say was a theta of n times, plus step 2, where cumulative count was being done, that time you can calculate, plus step 3, where you have each AI being placed at index of the sorted array. Effectively, that is n times loop. So I can say this will be theta of n. So if this step is not more than theta of n, then the time complexity will be obviously not more than theta of n. So you can calculate how much will be this, and then accordingly, total will be theta of n plus whatever comes here plus n, and then accordingly, if this value is less than equal to n, then the total will be theta of n. But if this value comes out to be more than n, then we are not going to get it done in linear sort. So your target should be to do this work in less than equal to n times. And that is possible easily. Secondly, now you can easily see why values in the small range were needed. I needed a small k, k to be less than equal to n. Why? You can easily see this step is actually going to work over steps will be dependent on k, because my count array is k based. Count array is 0 to k based. So effectively, my step 2 will be effectively going to be probably theta of k. So my overall complexity comes out to be theta of n plus k plus n. As we know, k is less than equal to n guaranteedly, I can claim this to be theta of n. I can write this to be, let's say, O of, or I'll say O theta of n plus n, or I'll say theta of n plus O of n corresponding to this. This is theta of k. Theta of k can be straight away said to be equivalent to O of n, because k is less than equal to n. So it will never be more than On. So upper bound is guaranteedly. So I can say overall, I can say the time complexity is theta of n. But this was possible only if k was less than equal to n. So that a star condition which we said is needed ensures that my total time complexity is not going to be beyond linear time. Continuing further, let's have the radix sort discussed. So radix sort effectively says we will be relaxing the condition of those single or values in the small range. Say, earlier I said values in the small range, in range 0 to k. Bigger values will not be probably possible. What about bigger values sorting? Does that mean that they cannot be sorted in linear time? Well, yes, there is a solution. Any idea how the word radix comes? Yes, the word radix. It effectively leads to the base. In our context, we are using it as a base of the number system. So for our discussions, this radix word will be connected to base of the number system. For example, my decimal number system works with base 10. So it has a radix 10. My octal number system works with radix 8. Hexadecimal works with radix 60. So I will use the radix now along with counting sort to do sorting in linear time for bigger values. So I will be able to probably do the bigger numbers for radix sort based linear sorting. Again, some conditions apply. What is the condition for radix sort? For the time being, I assume that the values are not negative, positive values. First thing, for the time being, assume that have same digits, same number of digits. Although this is not a compulsory condition, but for the time being, we assume same number of digits in each value. So this star, again, star will be relaxable later and we will be able to solve, but understanding will become easy through this process. So, for example, if I say 3-digit number, so that will mean all values are something like 100 plus onwards up to 999. 100 onwards up to 999. 238, 534, 272, 562, 983, 325, etc., etc. Now, if I have to sort these numbers, of course, directly counting sort not applicable because the numbers are, say, n is equal to 50, but the values are going up to 999. So k is not less than equal to 50. Hence, we cannot say that directly radix sort can, counting sort can be used. But you will be surprised to know that the concept of radix sort probably came from observing how did you do sorting in your class 2 and 3. You must have done these numbers arranged in ascending order in your class 2nd or 3rd. And at that time, you must have found it very difficult to arrange. And maybe many a times you might have done mistake in during class 2 or 3. But probably the scientist who designed this radix sort observed his grandson or granddaughter or son or daughter to do such ascending order sorting. And then he got the idea and then designed the radix sort. Well, you must be again surprised that why your father or mother or your grandfather or grandmother didn't get this idea. Well, that's just a lighter side. But yeah, effectively, how did you do at the school level in the class 1-2 level? So if I say that you have values, let's say 238, 537, 933, 708, 103, 101, 922, 130. Maybe you had this number. How did you sort them in ascending order in your school? And just remember, in your school, if you had certain values as a 2-digit, certain values as 3-digit, and certain values as 1-digit, then their mistake probability was more. To avoid such mistakes, radix sort assumes 3 digits or same digits. Well, that's not the exact reason, but because algorithm will work correctly, don't worry. But yeah, at the school level, you assumed that and probably did your coding through that process. Just recall, how did you do that at your school level? So what you did was started the values with, let's say, 1. If all numbers are 3-digit, you first of all find which values start with most significant digit as 1. So out of this, now you have to compare. Then you say, okay, probably you compared 2nd digit and you found 3 is more. So first of all, you have to consider these 2. Then 2nd digit also same, you compared these values. Of course, you did comparison. Now we are going to do it without comparison, but logic is similar. So first of all, you said 101 is the best. Then you said 103. And now because 10 and 10 both values over, then you say with 130. Similarly, you go for value with 238. Then you say, okay, next value with 3, nothing exists. Value with 4, nothing exists. Value with 5 as a first digit, one value exists, straight away 537. Value with 6, nothing exists. Value with 7, 708, copied. Value with 8, nothing happening. Value with 9. Most significant digit as 9, 9 as 100 place. So you have to compare these. 9, 9 same, then you compare second digit. Most significant digit, then second significant digit, and then you find 922 covered, and then you go to 933. This is how you did. Well, radix sort also does more or less the same. The only thing is, instead of comparison, it will use internally counting sort. So what it says is, based on one digit at a time, use a counting sort and do the sort. So effectively, above logic could mean, say, use hundreds place digits for above numbers and do counting sort. So from that process, effectively all values with hundreds place as 0 will come into count 0. Similarly, hundreds place digit. And because each digit is in the range of only 0 to 9, I can say for counting sort, k equal to 9 for counting sort. At a time, I need only 0 to 9 as a 10 values, and for counting sort, k tells the total range of the values. So at a time, one digit being talked. So counting sort position or counting will be using 0 to 9. Values will actually remain bigger than that, because that is the total values are bigger, but at a time I will decide on basis of this. And accordingly, I will use this. I'll say use hundreds place. That is first step. After that, use tens place, digit, and do the counting sort. Now, in this case, the concept of a stable sort helps me. Stable sort is guaranteed. So if the values with the same most significant GAURANTED. So if the values were already sorted at hundreds place and they were same, their relative ordering will still maintain. So if the all values with 100, 1, 3, and 130, they came together in some order, that order will never change. If the hundreds place was the same and tens place is also same, they will remain in the same relative order. And then later I can do that as using ones place digit. You can again sort the same value, and then finally your sorting is ready. So I will say using tens place sort, then using ones place digit sort, and done. But again, we will go into further simplification of this. What we are going to do is, let me just save this and create one slide here. So let me just have some new slides so that my ordering doesn't get disturbed. Yeah, so I'll have here continuity. So now I say radix sort, either I could go to most significant digit to least significant digit. Still, it works fine. But the beauty of this algorithm is that you can also have the change. If you go LS2 to MSD also, still sorting will happen. And you will be surprised. It doesn't appear to be a good logic initially, but it is correct. What it means is, let's say if you have values, say 238, 103, 937, 258, 257, 103, 952, 10, I'll make it as 108, say 101, then say 924, again 106. If these values were being sorted, I say sort on base of a most significant digit. That will mean effectively all values with least significant digit as 1. So they will come at the initial position. Let's assume some other value also, say I will make it as 901, 931. So I have two values with 931 and 101. And let's assume I have one more value, say 731 as another value with this. 731 will come initially. Similarly, the values ending with digit 2, 952 will come next. Then will come values ending with digit 3, and they will be in the same order. Remember this order, because this 931 is before 101, relative ordering will be ensured because of a stability. So this order is guaranteed if they have the same LST. Then 952, then 103 comes, no other value with the 3 digit. Then I have, let's say, some more values with value 6 at the end, 106 will come. And then I have value 7, 257 will come. And then I will have 238 and 108. Again, for these two values, relative ordering will be guaranteed. How did I get this? This I got using counting sort. So in counting sort, the decision where this counter will be incremented will be based on LSD. Counter will be incremented based on LSD only, but the total value will be copy paste as if it was a full record. Counter will be incremented using LSD only. So my K is safely as 9, 0 to 9 values are there. All digits LSD are in this range, so K is 9. And so counting sort is applicable. Now, the good part is second time you will do it on not LSD. Now tens place based sorting will happen. So tens place based sorting will mean based on 3, based on 0, based on 3, 5, 0, 0. Obviously, the values with the 0 will come first. So you can see now 101, 103, 105, 106, sorry, and 108. They will come initially based on count 0. You can easily see relative ordering of this is ensuring the corresponding least significant digit order. So if initial digit doesn't change, most significant digit doesn't change. For example, this could have been 3 also. If this 3 is there, later this will shift somewhere. But if it is initially not 3, still the same works continues. So this relative ordering has indirectly kept them in the correct order. If any most significant digit could have been higher, it will shift somewhere. For example, you could see here after 0, the next value will be with value 2, nothing exists. Then I have 931 with value 3, 731 with value 3, and 238 with value 3, and then I have value 5, that will mean 952 and 257. Now the values are sorted on based of value 3 and value 5. So middle digit, tens place digit. After that, next time, hundreds place based. So now the sorting will base on this one. Obviously, these values remain correct. Had there been, let's say, 306, this could have gone somewhere else. But relative ordering of these values maintained. Now just see. This is a 9, so it won't be used. This is a 7, not used. A 238. So straight away 238 comes here. Then 257 comes here. This was 257. 257 comes here. Then 731 will come. Then 931 will come. 952 will come. These values relative ordering ensured. 238 versus 257, their relative ordering ensured. And automatically they all become sorted. So this is how radix sort can work from least significant digit to most significant digit also. Then in the book, the solution given or original radix sort suggested to go LSD to MSD. Question is why? So in computer science, no decisions are made without any basis, without any sound logic. This also has a logic. Although it works MSD to LSD also correctly, most significant digit to LSD also okay, but suggested was to go from LSD to MSD, although in your school you did it from most significant digit. Then the reason is programming wise, finding LSD is easier, and once LSD found, then MSD can be found in the next step. LSD found in one step, and once you have LSD from previous digit, from there, next digit can also be found in unit step. So you can find out in unit step. Once you have found one digit, or maybe next time you want, for example, initially you want to find out, say some values there, 238, you will just have, say, divide by 1 and take percentage of 10, you get 8. Next time, this dividend or this exponent has to increase. From here, you have to go to tens place. So you say 1 into 10. So that means you have to now divide by 10 and then extract 3. So you will be able to do. Then you have to take from 10 to 100. So you will be able to extract 2, because by dividing by 100, you can get 2, and then accordingly you can calculate that. Similarly, from 100 to 1,000, 1,000 to 10,000. So progressively, you can just keep on multiplying by 10, and then next power can be generated. Next exponent can be generated by 10 into previous exponent. So that way, starting from LSD becomes very useful, and unit step calculations can be done. And if it is not unit step, then we will not be able to do it linear time. So needed this so that linear time you can sort the algorithm for linear time sort. Because I want counting sort not to have any extra loop to calculate power 10 power k or 10 power n. If I have m digits, 10 power m to be calculated if total m digits are real. So 10 power m should not be calculated using exponent function or using a loop, because exponent function also internally uses a loop. So total m digits if there are 10 power m should not be requiring a loop to be computed. LSD onwards will make this possible in unit time. So effectively, my radix sort says nothing but I will say if my total digits are m, let's assume total digits are m, then I will effectively say nothing but for I equal to 1 to m, do counting sort using ith least significant digit. That is it. So I have to modify my original counting sort logic. Earlier, you had a count sort being called, say, using array and size. But now I would like to know the digit position for sorting and use this digit position. So initially digit position will be sent as 1, next time as 2, next time as 3, and up to m. 1 means effectively ones place, 2 cent will mean tens place, 3 cent will mean hundreds place, and so on. So using this, you should be able to do the sorting. Well, I'm not going to write code beyond this. Complete the implementation and think how can you improve this. Next class, we are going to see how to solve this. Then another important point, can you have negative numbers? How to handle that? Further, if number of digits are not same in each number, can we handle that? So, are not same, I will say. Although radix sort sent that we should have the same digits, but what if they are not same? So I think whatever logic we made can easily work, will make, should work, because in that case, automatically 0 will come out if the digit doesn't exist. And in schooling also, probably the way we solved it was by assuming the total digits to be same. For example, if I wanted to sort 703, 932, 87, 56, 2, and some similar values. So we converted these to 3-digit values. And then things become easy to solve. So if I convert like this, let's say similarly, I had value 5, I had value 2, 9, 238. So I converted these to each number as 3 digits, and then mathematically or as a school child, I could easily solve. The same thing I can easily probably do here. So I can easily do here also the same work easily, but I have to find out an answer for this, not immediately. So first your aim should be to implement for 0 onwards numbers. Once you are able to solve that, later you should aim to think of a solution to do this. With this, we will wind up. Let's hope that you are clear with all this. And next time you will complete this, and then I will be able to show you or discuss the code once you are next time meeting, and if you have any doubts. So let me just stop my class here, and I think the class is already over. Okay, that's very much. सारा बेकार पढ़ाया हुआ। Yes, over. Stop.